Hello everyone, today's lesson is going to be on quadratic sequence. And the lesson will start in about 2 minutes. It's my first time here, so please bear with me. Trying to get used to with the old technical stuff. I hope you can hear me. I have no idea how to find out. So maybe if you can post a comment, saying that you can hear me or something like that. One more minute to go. This could go completely pear-shaped. Yes, OP. You missed, I think, enough lessons by now. Thank you, Tabin, for letting me know. You better be fine. I'm using a Blue Yeti. Great, Amar. AM4. Now we're talking. I know I've been through quadratic sequence a few times in lesson, but I thought I'd pick this topic and it'd be a good test for us. If it works out, that we can do more of the lessons and Owen can stay at home more often. If you think anyone else could get benefited from this lesson, please do let them know. Okay, let's start the lesson. Now, I hope you can see my screen. What is the nth term of 2, 5, 8, 11 and 14? Have a guess. Well, not guess, find out. Can you post your answers on the comment sections, please? So A is 2n, B is 2n plus 3, C is 3n minus 1, and D is 3n plus 2. Definitely B. We'll find out soon. Waiting for a few more. Amar, C. Tab in C. Any more answers? Last 10 seconds. Zach the Boss, C. I like that name. Thinks he's the boss. Anyway, let's find out. It is C, 3n minus 1. I like your confidence, Owen, but unfortunately it was C. And how do we know it is C? Is because let's find the difference between the two terms. So what is the difference between 2 and 5, which is 3. So we got that 3n from there. Now substitute n with 1, which is 3 times 1 is 3, and take away 1 to get to 2. So 3n minus 1 is the nth term of this sequence. Okay, let's try one more, and then we're going to move on to the actual quadratic sequence lesson. Okay, we got Ahmed Chuni. I'm here for the culture. So you know what? Whatever you're here for, you're here now. That's what counts. Don't worry, Pat Owen. I've got it covered. He wouldn't show up. Definitely D. 15 more seconds. Put your answers in through, please. Amar says B. Tabin B. Zach B. Ahmed Chini B. Okay, let's find out. 3, 2, 1. It was B. Okay, so for the difference between 1 and 6 is 5. So the first part of the answer would be 5n. Now, what do we need to add or take away from 5 to get to 1? So we take away 4. So that gives us 5n minus 4. Ali is here as well now. Welcome. Now, let's have a look at this one. What is the n term of minus 1, 5, 15, 29, and 47? Have a think carefully. Let's find the differences. Minus 1 to 5, 5 to 15, 15 to 29, to 47. Okay, you probably guessed it by now. This is a quadratic sequence. We cannot find the linear n term for this one. We need to follow the quadratic sequence procedure to actually find the n term. Okay, it was none of these. Well done, Ahmed. Owen, well done. Okay, now let's have a look. What do we need to do in order to find the n term of this sequence? Now we know it is a quadratic sequence. Let's find out. Okay. So here's our first example. So I'm going to use this question as an example. Minus 1, 5, 15, 29, and 47. So what we need to do is, first of all, find the first difference. And the first difference, we have 6, 10, 14, and 18. Now, these differences are all different, therefore, we need to find the second difference. Okay, now once you find the second difference, we'll see what we get. So 6 to 10, 10 to 14, 14 to 18. And every time we can see that the difference is 4. Okay, now because the second difference is the same, we call the sequence quadratic. And we know that equation will have an n squared in it. Okay, this is something you have to remember, that a quadratic sequence will have an n squared in it. Okay, so let's have a look. Once we found the second difference, all you have to do is halve the second difference, and that will give you 2n squared. And once you got the n squared, all you have to do is write the term, so you can see the table below here. Write the term number given in the question, substitute the numbers 1, 2, 3, 4. You can do more, but up to 4 is fine. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared, 16 times 2 is 32. This is where we got these numbers from, by substituting 1 to 4 into 2n squared. Now once you found this, all you have to do is find the difference between the term and the 2n squared values. So minus 1 take away 2 is minus 3. 5 take away 8 is minus 3. 15 take away 18 minus 3. 29 take away 32 is minus 3. So every time there's a difference of minus 3. So all you have to do is add that minus 3 into your first part of the answer. And first part of the answer was 2n squared. So our answer is 2n squared minus 3. Let's do another example. So let's do 5, 14, 29, 50 and 77. Okay, I've got my OneNote up now. I can write on this. Oh, sorry, before I start this, let's quickly go through the comments. I just carried on like there's nothing going on. Let's read some of these comments. Okay. Ronaldo's going to score. Who are they playing? This is educational. Very thanks. Okay, Owen, when you come in. Okay. Anyway, let's go to the examples. Okay, so we have 5, 14, 29, 50 and 77. Now, like we said before, find the first difference. Okay, so 5 to 14, find the difference. So 14 take away 5 is 9. Then is 15, 21, 27. Now find the second difference. Now because the first difference is all different, we need to find the second difference, because we know for definite that is a quadratic sequence. In an exam question, they might not tell you that it is a quadratic sequence. So you will need to find out. Sometimes it will tell you, sometimes it not. So if the first difference is different, you will definitely know that it is a quadratic sequence. Now let's find the second difference. 9 add 6 is 15. 6 and 6. They're all positive 6. I think the ink is a bit too big. Okay, so this time we got 6, the difference. So like we've seen in the example before, we have to halve the 6. So 6 divided by 2, that gives us 3. Now the first part of the answer is going to be 3n squared. So we found the first part of the answer. Now draw the table. I'll get rid of these so I have enough space. Now let's draw the table. You don't need to draw the table. Actually, I won't draw the table because in an exam you don't want to waste time drawing a table. So it is not necessary to draw the table. So I'll just write down the term numbers. So what happened there? Okay. Okay, now first of all write the term that is given. 5, 14, 29, 50 and 77. Next thing you have to do is you got 3n squared. All you have to do is substitute the numbers 1, 2, 3, 4 or even up to 5 you can do into 3n squared. So 1 squared is 1 times by 3 is 3. 2 squared is 4 times 3 is 12. 3 squared is 9 times 3 is 27. 4 squared is 16 times by 3 is 48. And 5 squared is 25 times by 3 is 75. Okay, now find the difference between these two. So the difference between the term and the 3n squared answer. So the difference. So 5 take away 3 is plus 2. 14 take away 12 is plus 2. 29 take away 27 is plus 2. So every time you can see there's a 2 plus 2 difference. Okay, now we can complete our answer. So we had at the first part we had 3n squared, and all we have to do is put this next to the 3n squared, so plus 2. So we found our quadratic nth term, which is 3n squared plus 2. Now, one good way to check your answer is by substituting the number 1, 2, 3 into your quadratic nth term. So let's have a look. So let's substitute 2 into it. So 2 squared is, so 3 times 2 squared plus 2. So that'll give us 2 squared is 4 times 3 is 12, add 2 is 14. Our second term is 14. So it does work. So we got the right answer. Okay, let's quickly get through some comments. If you had any questions, let's see what questions do we have. Okay. I can't see any comments to do with maths actually. I like this car. Yeah, it is not my car, it's just a screensaver. But thank you anyway. Okay. Good to know. Slim Jim, where you live. Okay. All right. Good to know. Okay, Owen, you don't understand. I'll go through one more example and hopefully that will help you. Okay, now let's get through one more example. Let's go back to our PowerPoint here so we can find more questions. Okay, let's have a go at this example here. So we have 5, 11, 21, 53. Let's find the difference first. So we have 6, 10, 22, 'll just double check that, because 53 take away 21 is 2, 5 take away 2 is 3. Okay, always check. Now first difference is all different, so let's have a go at the second difference. Is 4, 12, 22. Now I think I made a mistake on the question, so I'll just quickly go and check the question. So let's get rid of all that. So we have 5, 11, 21, 35, 53. 5, 11, 21, 35 and 53. Okay. Okay, now guys, a bit disappointed with the comments. It was meant to be comments to do with your learning. A lot of the comments, I'm not sure whether they are of any use to do with quadratic sequence, and I was hoping that will actually help, but unfortunately this is not helping at all. Maybe it would help if I stop the comments. What do you think? Well, if it comes to it, I'll probably start banning people. Your loss. Okay. Now I think, can you just comment? So I can see it about 24 people here. Now this example was only useful for people who are doing higher. Now if you are doing foundation, can you just comment with foundation? So I know how many people are actually doing foundation. Then I can maybe choose a topic which will actually help you with foundation. So we've got 1, 2, 3, There is no such thing called intermediate anymore. Used to be one time. 5. Six. Okay. So there are a good number of people who are actually doing foundation. Okay. So in that case, I'll go through some examples of linear sequence. 2, 5, 8, 11, 14. So we have 2, 5, 8, 11, and 14. Now I want to find the nth term of this sequence here. So first of all, you find the difference between the second term and the first term. So you do 5 take away 2 is 3. 8 take away 5 is 3. So every time we have a difference of 3. So therefore we know it is a linear sequence. Okay, so your first part of the answer is going to be 3n. Now we need to find the second part of the answer. Now how do we find that? Let's substitute 1 into this term here. So we got 3n. Let's substitute n with 1. So that will be 3 times 1, which is 3. Now look at your term in the question. The first term is 2. Now what do I need to do in order to get to 2? So I need to subtract 1. Now this subtract 1 will go next to the first part of the answer. So the n term is 3n minus 1. Okay, comments. 3n minus 1, yes, well done. Mini Dashman. Who else gave me the answer? Azhar Ahmed, well done, Azhar. I'm only reading out the answers, guys, because I have no interest in any other comments. Yes, Balrai, it is a linear sequence. Okay, it has been quite a while since we start streaming. So what I'll give you guys 2 minutes break. So I'll put my mic on mute. I can see from some more people giving me the answers. Yes, it is, because you can see it on the screen. Did you try it? Okay, so 2 minutes break. You guys worked hard in the comment section. And I'll be back soon. Okay, welcome back everyone. Well, it's not like I don't think any of you left. Still got 22 people. Anyway, we are going to do index rules because quite a lot of people are here for foundation. So I think it's only fair that we do something that helps everyone in here. Okay, so index laws. So let's go through some basic laws first. So when we have, say for example, a to the power of n times by a to the power of m, when we times, we add the powers, so it'll be a to the power of n plus m. Okay, and let's have a look at an example. Say for example, we have a to the power of 2 times by a to the power of 3. The answer would be a to the power of 2 plus 3, which is a to the power of 5. Now what would a lot of people do is, and they'll actually times the 2 and 3 and they'll write a to the power of 6. This is wrong. Okay, so when you times, you add the powers. What happens when we divide? Say for example, we have a to the power of 5 divided by a to the power of 2, and when we divide, you take away the powers. So that's the rule. So a to the power of n divided by a to the power of m, you write it as a to the power of n, take away m. But remember, it is not a to the power of m take away n. Over here, n comes first, so you're going to take away m from n. Okay, now let's have a look at this example here. So a to the power of 5 divided by a to the power of 2. So it'd be a to the power of 5 take away 2, which is a to the power of 3. Okay. So just to recap, when you times, you add the powers. When you divide, you take away the powers. Okay, let's have a go at a exam style question. So again, it could be on foundation, possibly higher, maybe not. So a to the power of 6 times by a to the power of 4 divided by a to the power of 3. Now have a go at this question here. Just like I said before, times, you add the powers, and divide, you take away the powers. Have a look at this question, and can you post your answers on the comment section? You've got 1 minute. So we can see Azar Ahmed, 8 to the power of 7, Mohammed, 8 to the power of 7, Saif, Jazzy, 8 to the power of 7, 8 to the power of 7. Okay, well done. It is 8 to the power of 7. So let's do the top part first. 8 to the power of 6 times by 8 to the power of 4. So you add the powers, that gives us 8 to the power of 10. And divided by 8 to the power of 3. And because we divide, you take away the powers, and that will give us 10 take away 3, which is 8 to the power of 7. Brilliant. Okay. Now, another thing that you might need to know for your exam is equation of straight lines. So how do we actually find equation of straight lines? I just quickly recap and give you the formula. So y is equal to mx plus c. So you need to find the gradient. You might not be given the gradient in your exam, so you need to find the gradient. So how do you find the gradient? Is rise divided by run. If that's something you have done recently, hopefully that will make sense. And c is the y-intercept. So you might be given a graph, and from the graph you might need to actually find the gradient and the y-intercept. And how do you find the y-intercept? Say for example, this is the line. The y-intercept is where the line crosses the y-axis. And how do you know which is the y-axis? Y to the sky. This is how we know this is the y-axis. So this is the c value here, and the gradient is rise divided by run. So count the coordinates, find the coordinates, and find out what the gradient is. Okay, let's go through some negative indices. Again, this topic could be on foundation and higher both. So for example, if we have 5 to the power of minus 2, how do you actually evaluate this? Okay, so 5 to the power of 2. Now there's one rule you have to remember, is anything to the power of minus 1 is always 1 over that term. Okay, say for example we have a to the power of minus 1, so it is always going to be 1 over a. Okay, if you have a to the power of minus n, it was going to be always 1 over a to the power of n. So you probably guessed it by now. 5 to the power of minus 2 is going to be 1 over 5 squared. And all you have to do is simplify 5 squared, which is 1 over 25. Let's have a go at another question where you could possibly have a fraction and a power. So we could have, for example, 3 over 10 and square all over it. When you have a question like this, you have to remember that it is squaring the 3 and it is also squaring the 10, because you've got brackets all around it. So we're going to have 3 squared over 10 squared. So 3 squared is 9 and 10 squared is 100. Okay. Let's have a go at another one. Fractional powers. So for example, if you have a to the power of half, anything to the power of half is always going to be square root of that number. So a to the power of half is equal to square root of a. So for example, if we have 49 to the power of half, it is going to be square root of 49, and simplified of square root of 49 is going to be 7. Another rule could be a to the power of 1 over 3. So if you look carefully, a to the power of half is square root of a. So a to the power of 1 over 3 is going to be cube root of a. So cube root of a. So let's have a go at the question. So you could be given 27 to the power of 1 over 3. So that will be cube root of 27, which is 3. Because 3 times 3 times 3 is 27. If you are given a to the power of 1 over 4, that will be 4 root a. So if you get a question, 16 to the power of 1 over 4, that would be 4 root over 16. And which number times together times by itself 4 times gives me 16. So we can say it's 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's going to be 2. Now let's have a go at a more complicated indices question. Now that we went through all the simple rules, let's have a go at 27. Now this probably applies to higher students only. So if you're doing higher, you should be able to answer this. So 27 to the power of minus 2 over 3. So we've got a negative indices. So before we looked at what happens when we have negative power, it always becomes 1 over. And because it's 2 over 3, so because when we had 1 over 3 to the power, you always cube root. Okay, just before we have a go at this question, let's have a go at this question here. So for example, if we have 8 to the power of 2 over 3. Now the 3 at the denominator in the power will go as a cube root of 8, and the 2 here is going to go outside as a power. So let's do cube root of 8 first. Cube root of 8 is 2, because 2 times 2 times 2 is 8. So it'll be 2, and we still have the power out there, which is 2 squared, which is 4. Now, only difference in this question is it has a negative minus 2 over 3. So negative 2 over 3. Now, have a go at this question. You might need some pen and paper. And can you find the answer and post it in the comment section? I'll give you 2 minutes for it. And your 2 minutes starts now. Yes, I do have my watch with me. Okay, hope you had a go at it. I can see a -9, 6, -9, asterisk 6. Owen thinks it's definitely 18, and then Mahmud 6. Okay, now let's have a look what it actually is. Now, like I said, you just have to follow all the rules I just showed you before. So 27 to the power of minus 2 over 3. So because it's a negative power, we can write it as 1 over 27 to the power of 2 over 3. So the power becomes positive now. And now all you have to do is, because the 3 and the denominator becomes a cube root of 27. And the 2 goes outside as a square. Now, first of all, do the cube root. So it's still 1 over. Cube root of 27 is 3, and the 2 as a square. So 1 over 3 squared is 1 over 9. Okay, now some of you did say 9. Fish tank. Yes, it is 1 over 9. Well done. Okay. So well done to fish tank. One over 9. Okay, now I think I would call it a day. What a night. I'm not sure if it was useful. Now, if you think you found this useful, I know it's my first day on live, so I'm still getting used to it. So hopefully next time it will be much better, and I'll bring some more resources to the online lesson, and hopefully that will help. But if you think that actually helped you, maybe hit that like button so I know how many people liked it. Or if you want to see more future videos on live streams like this, then let me know. So what I'll do is next lesson I'll do foundation one day, do higher one day, and hopefully that'll be much better. So in that way, the higher and foundation people won't clash in the comment section. And sometimes it is not possible to actually revise in lesson, in class all the time. So hopefully this is something that we can start doing now. Now, please do let me know if it helps though. And the only way I can know, I see 29 people watching at the moment. Well, 28 now. If I think I can get at least 20 likes or 25 likes, then hopefully I'll know that actually will help you something in the future. Maybe this lesson didn't help you, but hopefully future lessons will. And please do let me know if you see me around in school. Let me know which topics you want to go through, and I'll keep that in mind. I know different people will have different topics to go through, but I'll see which topic more people actually want to go through, and in that way I can actually go through that. But thank you very much, everyone. And it is Mr. Mahmud helping you do better in maths. Or shall I say Y to the sky? I think I heard Y to the sky in my first week of releasing my first video more than anything else, starting from all the way from year 7 to 11. So thank you guys for that. At least you showed your appreciation through telling me Y to the sky. At least I know you watched it and you liked it, and hopefully helped you as well. And that's the main purpose, to help you get a better grade. Simultaneous equation. Okay, I'll keep that in mind, so we can do maybe simultaneous equation. Okay, goodbye everyone. Have a nice evening, and good luck with your mock exam tomorrow. How do I stop this thing?